Hi everyone. Yeah. So in the previous class, we were talking about the basic background of the cryptocurrency and Bitcoin. How the digital currency is useful in a peer-to-peer network with requires some security for exchanging the unit value to purchase anything or to transfer the uh, kind of cash in the digital system. Then it gives some kind of background information, why this new technology introduced, and what kind of research work have been done on that one. So today we try to discuss what is a blockchain. That so as we saw that the information will be maintained in terms of blocks, and those blocks will be updated with any new transactions, and those new transactions will be maintained. So after adding some new transactions to the existing block, the new block will be created. And once new block created, if any transactions updates have been done in that, suppose maybe some transactions may be added, some transaction may be deleted. In that case, again a new block will be generated based on the previous block. So there is a chain system that you can find that the next block will be created based on its previous block information. That block will be created based on its previous block creation. And every block is related to each other, so we can say that there is a blocks of chains. So before understanding that, let us have one the background information of a case study, and from there we can better understand why and how this blockchain will work out. So let us, yeah, yeah. So let us consider one, the supply chain management system as a case study, and how it happens in generally, so that that in the supply chain management system information, how it can be exchanged in the among the users or between the users, and who will maintain this information, where it will be maintained, if it is maintained by any individuals or group of people, or if it is maintained, then what is the the security, or what is the validation for those the blocks which are created, that we try to discuss in this, right? So here we in supply chain management we will see the players and the game in that case. So let us assume in a crude the chain system, crude refinement system, or in our Indian oil system. So we'll see one by one in supply chain in petroleum industry, basically. Okay. So if you see that from where in the petroleum industry the actual task starts in your idea. In petroleum industry, what is the first task which takes place in petroleum industry? Pardon? Finding petroleum location. And from there you need to get some raw material from the crude. So from there the task starts in the supply chain system. Correct? So it starts with the part of finding the locations, and getting the crude oil first. So crude oil purchase will be done first in step. And once that crude oils are they find out that purchase, then they are going to store that the crude transportation will be take from its location to the different locations. And then from there, the by using this crude transportation, it may goes to different locations, and after that, that crude oil will be stored in some the crude storage, and from there the distribution starts. And after storing, purchasing the crude oil, transporting it to a storage location, the crowds, the crude storage, and after that it will go through the process of refinement. So after refining the crude oil, and from there it is going for the distribution to the various oil stations or gas stations, we say. So that transportation will take place. Then after refining, the refined oil will be, refined gas will be transferred, distributed among the stations, the retail stations. So these are, few steps, involved in the supply chain of your petroleum industry, basically. Okay. So in this case, the question is, the how this supply chain petroleum industries will work together, because different entities are involved here, right? One entity is crude purchase entity, then the transportation department involved, then the storage, the department involved, then refinement involved, then again the small unit transportation or distribution involved, and the retail stations are involved here, right? So these are different entities. Now consider these are, in the network of petroleum industry. So if you talk about these networks, we can represent this as the nodes. Every node, we can write that node 1 connected to your node 2. Then it is connected to your node 3. That is connected to your node 4. And so on and so on. And when these are all connected to each other, we call this is as your network. Which network? This is belongs to your petroleum, so we call this as your petroleum network. Correct? So now, in every stage, every entity in this supply chain, they involved and they need some information, right? They need some information. So what's that information? The requirements for successful of this, the chain supply, management system. What they required, they must minimization of the material procurement right from your crude oil, and then they must the minimization of your manufacturing capacity and the sales capacity. These are few requirements to make the successful of your supply chain. Another requirement is meet the demand numbers. As when there is a demand, huge demand, you try to supply huge gas. If there is a less demand, you try to supply the less gas demand. Another requirement that involves is the respond quickly to the market opportunities by purchasing the production shortfall from other players. So our first one is crude oil, one first entity. If one crude oil place, if it is unable to produce the more crude oil which is needed for the demand of the people, then they try to purchase crude oil from another entities and try to supply, as per the demand. Then the objective of each production unit, it may be your crude oil unit, it may be your crude oil transportation, it may be your crude oil, storage, refining, distribution, and your retail. Right? In every way, in every unit, would maximize the throughput and the margins. So if these requirements are fulfilled, then the procurement would purchase the feedback state with the best yields at the lowest cost that will make these petroleum industry, the successful in a supply chain pattern. So from here, what are the needs for this? Means in this case, it needs a strong coordination among the players, right? If there is a huge demand from the people, But if crude oil is unable to produce the crude oil, the amount of crude oil which is required for the demand, then the coordination is not missing. Or, when the crude oil is transporting from one location to the another location, from crude oil to your crude storage, in that case, if transportation get delayed, again it will leads to the not fulfilling the needs of the demand. So there are certain challenges are there, and every unit they must be coordinate each other so that the supply chain system will become successful. So first and foremost thing is, when different entities involved in one network, the coordination is required among the nodes. Correct? And second one is, how do we obtain the real-time information from each stakeholder? It may be from your crude oil or your transportation. How do we get the real-time information? And third, comes into the event that, is it possible to reach the requirements of your successful supply chain by using a web-based portal? In web-based portal, something may happen. Correct?
Yeah.
Then again, there is a, the coordination will be missing. Then coordination missing, then it will not, reach to the goal of your supply chain system. So then, what is the guarantee that the information submitted by each of these entities is correct? Okay. Yeah.
Generally it would be that it's in their self-interest to submit the correct.
Yeah. So it requires some procedure, some method, some rules
trust
should be defined. Correct?
Yes.
Yeah. So, and third, to reach the successful supply chain system, then what if someone denies that the information later on, that no, I haven't given any information, this is not me, then how to handle that? Okay. First one is, coordination is required among these entities. Second one, who will maintain that? Is it possible through the web portal? If it is possible through web portal, then whatever these entities are providing the information, whether it is correct or not, that means authenticity is required. Okay. And third one is, no one should, if it is correct, authenticity is required, no one should deny that, no, this is not my information, I haven't provided. So, non-repudiation is required in this case. And then, how to maintain all these, to coordinate the stakeholders, maintain the correct information, maintain the non-repudiation. The answer for the requirements of successful supply chain, the answer is blockchain. The answer is blockchain. So how? If the answer is blockchain, then how can we obtain a real-time information from each of these entities in the network? Correct? So for that, everyone will maintain a information board we call the public bulletin board. So that public bulletin board will be available to every individual in the network. So for every information, right from the first step of your petroleum industry supply chain management step, that will create the information, and that information should be available to every entity in this network. So how it maintains that, right from the crude oil, it will say that 120432 barrels of production at the Mumbai highway, or in the Dallas, or in the Houston, or somewhere, that information on date and year suppose maintained. So then Along this particular information will be carried out along with the crude transportation department, so that there will be a coordination that how much the barrels are produced and how much it is transferring to reach the needs of the people, so that from this much amount of barrel produced at certain place at the crude oil location, then how much barrels are transported, because this transporter can take from other crude oils also, right? So how much barrels are transported from the one location to the another refinery station and so date and minute. So this how much it is carrying from the crude oil, that information will be updated by the crude oil transporters in the same public accepted bulletin. So then that information, the crude oil will be transported to your crude oil storage. At crude oil storage, how much it received, this entity in this scenario will be updated in the same, the block ledger. Okay, and after that, when it is transporting for refinement station, then your refineries will update that information. So at this point, the critical entities involved in this case is your crude oil transporter, and your crude oil storage. And they all together, some information is updated by your crude oiler, some information updated by your crude oil transporter, some information updated by your crude oil storage. So now see here, in a single public released bulletin, all the individuals, those who are there in this case, they all are active participants. They all are active participants, and they are adding some information into the public bulletin board. So now this information is available to everyone. Everyone can see all the logs and they can verify what is there in this public bulletin. So then, if any changes happens in this public bulletin board, so all those changes and those changes in this information is visible to every entity in the network, every entity in this network. Okay, so if keeping a single information block and that block is exchanged among all the units of your the network, then it achieves the first requirement of your supply chain system, that is coordination among all the stakeholders. Coordination among all the stakeholders. So then this board is not erasable, this is a permanent one. You may add additional information, but you cannot erase this. So keep that requirement as a note in the supply chain. Okay, you can add the information, but you cannot erase. So that the board is not erasable, so no one can deny later that I haven't write this information, this is not my information, cannot be denied by the crude oil. So with this, what happens? Non-repudiation will be achievable. No one denies that this is not my information. So that we call one of the information security standard, service security standard, we call the non-repudiation. That will be achievable. So then the simple one-step auditing here. So everyone, if they have any information, they can add some additional information here, but they cannot erase this information. So it is a simple one-step auditing. Once it is edited at this, that is visible or available to every entity in this network. So then it achieves the peer-to-peer information. Peer-to-peer information exchange. So then the question comes that who will maintain the bulletin board then from these entities? Is it by crude oiler? Is it by they are able to add the information, but who will create, who will maintain, where it will be maintained, if it is maintained at a particular location, whether it will be securely stored or not, who will take care of that?
Isn't it? Each node effectively has their own copy of this. That way, if one of the boards is faced or attacked, you have backups, and if there's a question of if like an audit, if irregularity is found, you can go to other different copies to counter check.
Yeah. So control check is one, but that comes later. You're right. But there should be a backbone infrastructure to maintain this one, right? So where it will be maintained then? The backbone infrastructure is required to maintain cloud. Yeah. So if cloud is there, means everyone can access to cloud. Okay, cloud is one solution. Good. Then who will pay money for the cloud? Is it refineries will reduce to pay, or the crude oil purchaser will pay, or the transporter will pay? Who will pay? Again, that's a question part. Correct?
The entire network.
Yeah. So that's one solution, but who will pay is another question comes. The next, who will manage it? Okay, somebody paid money, maybe crude oil, or maybe the distributor. They paid money in the cloud, okay, for space. Then who will maintain that information? Is it maintained by the crude oiler? Is it maintained by the second entity, third entity, fourth entity, fifth or sixth? Who will maintain? That question arises. Who will manage it and who will provide the cost for it? That question comes. Then, if one of the enterprise maintainers can provide, or the private cloud, and they can give some solution, but in that case, what is the guarantee that it is not a fraud? Possible, right? So then then how to the check whether it is given information is correct or not from a private cloud part, a private parties. So then the in that case, it involves that everyone in the supply chain system, they must maintain, everyone maintain the same copy of the board, the public bulletin board information individually and independently. Individually and independently, so that they can come out of this issue. They come out of this issue. They come out of this issue. So for that, what's the answer? It requires, again, it's cloud means, if cloud goes fails, as we talked in the cash payments, traditional payments, if cloud goes fails, the entire system becomes fail again. So from there, you find there is a distributed system is required. In distributed system, the same copy will be maintained by every individual in this network, and they are independent from each other. If any changes happen in one at one entity, it must be updated with other entity. So there, the distribution means everyone can control that information. Everyone can involve in that information. So the concept comes distributed systems. Distributed systems. So from there, we find that they required a special method. But how to do that distributed system? Right? So there you find the mechanism called the blockchain. Called the mechanism called the blockchain. Okay, and I'll just pause here. Have you got some information, right? why blockchain is required in this case study. To make the successful blockchain, all the requirements should be fulfilled. That means there should be a coordination required among stakeholders. In that coordination, they should maintain accurate information, right? That means no one should later deny that this is not mine. So for that, you need to achieve you need to get the authenticity service first. Authentication is required. Only authenticated users can update the information. It may be adding or deleting some information in the public bulletin, right? And they must follow the non-repudiation service. And after that, this information should be available to everyone, and everyone should maintain this information individually and independently. So another infrastructure concept should be introduced that we call the distributed systems. So to achieve all those, it requires a special infrastructure or the technology we call the blockchain technology. Blockchain technology. So what is blockchain technology? What it says? The blockchain technology is a decentralized, multi-authority, networked information, the data storage and access system. The data storage and the access system. So what it says actually in this blockchain, as defined by this, the formal definition of your decentralized and the multi-authority network. So this blockchain is essentially, as said, the decentralized distributed database. Decentralized distributed database or ledger. So this follows the method that the first one is decentralization. So in decentralization, how it happens? No one is the owner of the information. Everyone in the network, they all are the owner of the information. They all are the owner of the information. So now see here, every entity in our case study, every entity are part of the blockchain method for achieving the decentralization. So decentralization is simple term. It means that the application or the services which are providing here, in our case, the public bulletin, which we consider in our case, okay, that continues to be available and usable even if a server or a group of servers, in this case, we may consider these as your servers to maintain the database of the incoming and outgoing crude oils here. So this service will be deployed on a network a way that no server has the absolute control of your information. That means the control of your the information is distributed among every node in the network. First, and second one is, so this we call the decentralization, right? Then distributed means in the distributed database, which we can say every unit they maintains the database for any ledger or the information of that public bulletin data. So it will be maintained in the database. So database should be distributed. So this means that every node in this network is connected to every other node on the same network. So we call it as a distributed database. That means your crude oil is connected to every other node, and your crude oil storage will connect it to every other node. Your Indian the retailer also connected to every other node. So you can find if there are 4 entities involved, for example, then your node 1, your node 2, your node 3, your node 4, they connected to every other node in this network to achieve the distributed mechanism. And the third one is in this block, so that will reach you the multi-authority network. Everyone is having the control over the bulletin. And then the ledger will be used. So in ledger, this is an accounting information which we have seen in this case. The previous one, the bulletin will maintain the information, how much the crude oil, produced the barrels, how much the crude oil storage received the barrels and stored and how much this the refineries distributed that the crude oil, distributed the refined oils. So every information which is maintained in this block, that block we call it as your ledger also in this case. Correct? So that's the formal definition of the blockchain system. So is it clear? In general view of blockchain, is it clear? All the entities are connected to each other. So it will achieve the peer-to-peer network property first. Okay, everyone is connected to every other node. So that will also achieve the distribution. Decentralization means the information is not controlled by any one node in the network, controlled by every node. Anyone can, they maintain the information. Okay, not centralized, it is decentralized one. Okay, so that we call this, if you recollect the case studies, the information, the public bulletin which is maintained, that copy will be available with every entity in this network. Every entity in this network. So it says that no one as the sole owner of the data, everyone is the owner of the data, but everyone has a copy of that data, so there is no central database here. If there is no central database, then what it will achieve? No need to store the information at a centralized place. So no need to purchase a space for that, like Amazon Cloud or IBM Cloud or any other cloud. So decentralized information. Correct? So where it is stored means this information stored at every individual.
If no infrastructure has been purchased, how is the information transferred to each node?
Yeah, that we'll talk about that.
Okay, great. Thank you.
So here the main part is no one will pay money for storing the information. So that's why it is up to the individuals to store their database. So database is not centered here, right? Everyone is having, somebody may have the smaller database, somebody may have a bigger database. Correct? So this database is distributed. Distributed database will be achieved. Now, here is a good question from ID, right?
Yes.
Yeah. So said, but how this information will be, exchanged. So there it comes the distributed network. Distributed network. Again, they are relying on the internet only. So they are said, the decentralized and distributed means in distributed one, everyone is connected to every other one. Every node is connected to every other. So it is their responsibility to achieve the supply chain system successful. They must connect each other. That concept comes in the blockchain system. So how it will be done then? Everyone holds exactly the same copy of the data at the same instance of time. So here, two terminologies. One is data, another one is instance of time. Time and data should be maintained. So when there is a information exchange between the nodes or among the nodes, that shared information should be checked whether the outdated information or the updated information. For that, time is required, we call them as your timestamps are added to every new information. Every new information. So we are saying that timestamps, how to maintain these timestamps again is a question that we are going to deal with this question also. Okay, but up to here, is it clear? Blockchain means it is decentralized. Decentralized concept is clear. Okay, decentralization means no one is owner, everyone is owner. Distributed means information is with everyone. Okay, distributed database is maintained, so there is no need of a cloud or something maintained for them. So the cost is reduced. Third concept is, the ledger. So information can be updated or maintained by everyone. So for that it requires date and time. On what date it was updated. So as soon as if any individual trying to update the information in the bulletin block, that information immediately pass on to all other nodes in the distributed network. So upon receiving the new bulletin board, the every node's responsibility in the network is they compare their existing bulletin board with the receiving bulletin board. First, they are going to check the date and time, whether the newly received bulletin board is new one or the older one is circulating in the network. Because the attackers can do that, right? To make everyone exhaust, old information will try to inject into the network so that your network become congested. So this is the job of attacker. So, but you need to protect your network from attacker. How you are going to protect means just comparing the bulletin boards dates and time. If it is older one, drop it. Don't forward in the network. By that way, the congestion control can be achievable here. Okay. So then, if you see, this blockchain is at the immutable append only. As we said that information can only appended but not erasable. So it is ever growing chain of your data. So the data once added that cannot be deleted or modified later, cannot be deleted or modified later to achieve the non-repudiation. So now see that in our case study, every entity in this network, they are trying to maintain a ledger. This ledger, this is just an accounting term. So think of it's the specialized storage and the retrieval of your data. So these ledgers, think of these ledgers that are available at bank, like something like that. So now if you observe in this case, every entity having the same number of ledgers or same number of the blocks in their information. Okay, that means some times ago the first ledger is created, after that the new information is added, after that another information is added. So there is how it is, first one is created, suppose here the the block B is created, and another information, suppose L is added to B, then B will be there as well as L will be there in that. Then in the next, if O is added, another information, then you'll have B, L, O will be there in the updated one. So that they can add but they cannot modify in this blockchain. If any new ledger is added, so that added information will be distributed to all other the nodes in the network to achieve the distribution part. So once something is added to the blockchain, it cannot be denied later that this is not information added by me. So this information is transparent to all the nodes in the network, so everyone can see what is going on in the system. So no one can, make any changes without others noticing to maintain the transparency among every node in the blockchain system, in blockchain technology. Okay, so whenever a block is created, that new block will be depending upon the previous block's information. Every block is created, every new block is created based on the previous block in this blockchain system. Okay, so that once, as said, the first block is created, and in that block, if new information, new production came from crude oil, so new production information, new produced barrels of information will be added. So from B0 block, your B1 block will be created with updated information, the updated info with time. We call this as your timestamps. So how to achieve these timestamps then? How to achieve these timestamps? So what can be defined from this? We can say that blockchain is a decentralized, immutable, appended only public ledgers. And it is decentralized as well as distributed. Decentralized as well as distributed. Okay, so is it clear what is blockchain means? Blocks will be created. Who will create? Anyone can create, because there is no ownership in the blockchain technology. Anyone can create block. Anyone can create block. Okay, but in that block, how the information is maintained means once block is created and some information is added, that block will not be modified or altered later. Okay, so suppose in our class, if everyone is owner of the block and suppose I am the first entity, I may create one block. In block, we are adding some information that cryptocurrency and information technology and cryptocurrency and Bitcoin technology course. And our course, modality is face to face. And then, our lecture series is so and so timing, and which we distribute among every student. If any student can add that, some information, suppose, on blockchain definition, if Ed is having, some additional information, he can add to that in that block. And that should be distributed among everyone. So where it is stored means it will be available with every individuals. So storage responsibility for every individuals. There are no centralized. Okay. So the additional information can be added, like in our course also. Every week we are going to add the new lecture, teaching material. But the previous lecture teaching material is not erased from the block of our Canvas course page. So that we can say the decentralization, distributed part. So that is the formal definition that we can give it to them. Okay. So then from this we are talking about everyone can add the information, right? Everyone can add the information. Let me just summarize. One can create a block. Okay. In that block, we are going to talk about what are the elements of these blocks in the upcoming lecture series. In that block, for identification purpose, block name is required. In that block name, we are giving the information of your petroleum industry supply chain information is maintained. Correct? So now, who is creating this? In our case, if there are 4 nodes, node 1, node 2, node 3, node 4. So in blockchain, anyone from this network can create this block. Once it is created, it is their responsibility to achieve the decentralization and your the distribution, that block information should be passed on to every node in the network. Suppose if it is this block is created by suppose node 1, that node 1 will send that copy of information to every node, this block, every node in the network. So the same copy is available with every node. Suppose after here every maintains the timestamp at t1. After another time at t2 time, the another name 1 is given and maintain the information of the same PISC by your node 4. Suppose this block is created by your node 4, then that node 4 will send that copy to every node in the network, so that your block, second block will be created and second block is sent to every node in the network. So upon receiving this second block at time 2, what they will do, every node will check, compare with the T1 block B1, a T1 block B1 is there, that is compared with the at time T2 with block B2. So then block 1 is erased and block updated block 2 maintained by every node here. So then how to believe that node 4 is giving the correct information, the right information? So it should require some kind of the security for this particular block which is created by the user N4, this node. So there we need some basics of the crypto techniques. To achieve these goals, we need some information about the crypto techniques. So what is that? We are going to talk about the cryptographic, the hash functions to achieve the cryptographic information CIA. CIA. C for your confidentiality, because the information which is there in those blocks should be confidential and it is only known to the nodes N1, N2, N3, N4. Because it is a distributed system, so anyone can, while transferring your information, anyone can attack and do some fabrication in that. So to achieve the active, to get out of your active attacks on this information while transferring from one node to another node, it must be achieve the confidentiality. Second one is integrity, we call. The information which is created by N1 in your block 1, while transferring that block 1 to other nodes in the network, that information should not be modified by any other third parties. So how it is going to be checked means integrity. And second one is who can participate in this network for exchanging information. Only authenticated users are required. So A stands for your authentication. So to achieve this goal, the network security services goal, because after all, it is using the internet infrastructure, network infrastructure to transfer the data from one node to another node. So from these three, the most important one is your, the confidentiality, your authenticity and integration. So these functions are, the achievable by a cryptographic technique we call the hash function. So we are going to talk about this hash function in detail, how it works, what are the different standards of your hash functions are there that we discuss. So in cryptographic, the technique, okay, there is a mechanism we call the key mechanism to achieve the confidentiality, integrity, and authenticity. There is a key mechanism we call. So this key have two different, the ways of definition. We call the private key, symmetric key, and asymmetric key uh, mechanism is there. Symmetric and the asymmetric key mechanism. So in symmetric and asymmetric key means for encryption purpose, same key will be used on sender side as well as on the receiver side. The same key will be used for the sending the information for encryption purpose and decryption purpose. Sender side will encrypt and receiver side decrypt that by using the same key for achieving the confidentiality and integrity and authenticity. Whereas in the asymmetric key, two different keys will be used. Two keys will be used. One key is used, key 1, used for your encryption purpose, and key 2 used for your decryption purpose. Key 1 is used for encryption and key 2 is used for your decryption purpose. Okay, so there the asymmetric key concept will be used. So this asymmetric key concept, we also say it as your public key cryptography. In public key cryptography means one key kept privately, one key distributed to the public. So we try to understand the basic concepts of this public key cryptography, which is useful in the blockchain technology. And then we talk about the digital signatures to achieve the integrity of the information among the nodes. They use the digital signature concepts. So there are many other techniques are there, but for blockchain, only these basic primitives from your cryptography and network security, only these three concepts that we are going to talk in cryptography. But okay, so we'll try to discuss this one by one. So before that, let me just close this. Use this. Okay. So we call this the basic properties which we use for our blockchain as the basic crypto primitives. We'll try to discuss this in this what we are going to learn in this basic cryptography. As we said, we are trying to learn the basics of how these informations will be secured by using the crypto primitives behind this blockchain technology. One, we talk about the cryptographically secured hash functions. We write it as cryptographically secured the hash functions. So what are the different cryptographically secured hash functions? What are the standards? We use that SSH 256 and 512 bit size that we are going to talk. And then we talk about the digital signatures to achieve the data integrity in the blockchain technology. So these hash functions basically used to connect these blocks, as we said, block 1, where block 2, in this blockchain technology, block 3, or block 4. So as the information is updated, the new blocks will be created and those new blocks will be distributed with everyone. So these hash functions, they basically use to connect these blocks from block 1 to block 2, block 2 to block 3, block 3 to block 4, and so in the chain for the tamper proof way. And whereas these digital signatures involved in this, the blockchain technology to achieve digitally sign the data so that no one can deny that, this is not my data later. So their own activities and also the others can check whether it is authentic or not. Whatever the blocks which are, the block of copy which are the share among these users, whether there's block of information is authentic or not. Check it out, right? So in cryptographic hash functions, it takes any arbitrary size of string as an input. So in this method, this hash function is a mathematical function. In this mathematical function, the hash function takes the any size of the message. So in our case, whatever the blocks that we are saying, that as the blocks are growing, their size will also grow, right? So in those blocks, the number of the messages or number of transactions are continuously growing. So those blocks will be given as your input, or any message we call the X message will be given as an input to your hash function, but it gives a fixed size output. This input size varies, but the output size is fixed. So it takes any kind of information, it may be that is available in the block, and that block is given as an input to your hash function, and it will produce a fixed size output. Fixed size output. Another property is this hash function is non-reversible. It's only a one-way direction. There is no two-way direction. It all if one fixed output is generated, and this fixed output will be given as an input to another another hash, it will give other output. But that is also the same output, but not from, there is no the backward process or the reverse engineering process in the hash function. So it gives the fixed size output. That fixed size, that depends on the whether it is 256 bits or 512 bits size, or the any other fixed size that is defined by the user. In our blockchain technology, we use the 256 bits, the fixed size output of this hash function. SH256 algorithm we used to say. Secured hash, the function of your 256 we will use here. And this is efficiently the computable by just converting the given input into a fixed size in the hexadecimal form. So if I give any message in terms of, suppose if I give the cryptocurrency, or suppose crypto message is given as an input to the hash function, it will give the output in terms of the hexadecimals, the hexa form. So hexa is a combination from 0 to 9, and capital A, capital B, capital C, capital D, capital E, and capital F letters are there. So total it used the 16 letters combinations. So any size of your input converted into the hexadecimal form with 256 in the size. Okay, so I would like to stop this session here. If you have any questions,